Hello and welcome to another exam paper walkthrough. Today we're looking at the third space learning practice papers. These were written before any papers have been sat. They've been written based on previous exam patterns though, so they're a very, very good source. I've found these really good papers. This is the higher tier paper 2, so this is calculator. For my calculator, I'm using quite an old-fashioned emulator just because I can get it on the screen nice and easily. I do have a more modern one, but I have to open a web page, so it just becomes a bit more cumbersome. Right, we'll kick straight off then with question 1. Okay, the scattergram shows information about the cooking times of various cakes. Here is some information about another 3 cakes. Plot this information on the scatter diagram. Okay, so the first one is, let me get my pen on. The first one is going to be plotted at the coordinate 750, 35. And that's going to work for all of them. So 750 is here and 35 is up here. So we're looking first cross there. Next one is 850 and 50. So I'm going for a cross here. And then the third one is for 720. Okay, there we go. What type of correlation does this graph show? Well, we've got it's going up. It's a positive gradient, so it's going to have a positive correlation. Use the scatter diagram to estimate the cooking time for the cake, which weighs 900 grams. So I'm going to draw a line of best fit. I would always encourage students to draw a line of best fit for this question. So I'm going to say that's roughly my line of best fit. And then I use that to read off the value that I'm after, so 900 grams. So I'm going to go up to my graph. And then from there, I read across. So I'm looking at a cooking time of roughly 50. So you might have a slightly different value based on your line of best fit. So if you're out by a couple, that's absolutely fine. Okay, here is a rectangle and a trapezium. The area of the rectangle is 40% greater than the area of the trapezium. Work out the length of the rectangle. So I'm going to call that value x for now. I'm going to work out a value for the area of the trapezium first of all. So it's going to be a half of 6 plus 9 times by 4, which is going to be the same as, I'm going to do the half of 4 first of all. So I'm going to say it's 2 times by 15, so the area is going to be equal to 30 centimeters squared. I'm then going to say that if the rectangle is 40% greater than the area of the trapezium, then I would need to multiply this value by 1.4. So that's going to give me 30 times by 1.4 is going to be 30 plus 12, so I think it's going to be 42. Let's just double check that with a calculator now. I always get a bit too brave with some of these. Yeah, there we go, 42. So the area of the rectangle is going to be 42 centimeters squared. So x times by 4 is going to be equal to 42. So x is going to be equal to 42 divided by 4, which is going to be 10.5. Right, question 3. A box holds 12 donuts. So I'm going to underline key bits of information. I always recommend students read questions like this 3 times. First of all, to get a feel for the question. Second, to take out the key information. And the third time, to check that you've answered it. The videos would be too long if I did that, though. So box holds 12 donuts. It takes 500 grams of flour to make 20 donuts. Linda needs to make 4 boxes of donuts, and she has 1.5 kilograms of flour. Does Linda have enough flour? So I'm going to say how much flour does she need? So we want to make 12 times by 4, so 4 boxes of 12. So we want to make 48 donuts. So 48 divided by 20 is going to be equal to 2.4. Let's just double check that. Nothing wrong with making a silly arithmetic mistake at the start of a question. So 48 divided by 20 is going to be equal to 2.4. So we want 2.4 lots of the flour. So 2.4 times by 500 is going to be equal to times by 500 is going to be equal to 1,200 grams, which is equal to 1.2 kilograms. So yes, she does have enough flour. And I'll just finish that by saying 1.2 kilograms is less than 1.5 kilograms. Okay, question 4. Solve the simultaneous equations. We can even make our x coefficients or our a coefficients the same size, whether that's positive or negative. If I make my a's, sorry, I should have said a's and b's, not x's and y's. If I make my a coefficients the same, I'd need to make them both 12. If I make my b coefficients the same, I'd make them both 6. So I'm going to go for the b's because it's a lower number. So I'm going to call that. So I'm going to call this one equation 1 and this one equation 2, just to make it clear to whoever's marking my paper my steps. So I'm going to do equation 1 and I'm going to multiply that by 3. That would give me 9a plus 6b is equal to 60. And I'm going to take equation 2 and I'm going to multiply that by by 2. And that would give me 8a minus 6b is equal to 25. I'm going to call that equation 3 and equation 4. And then I'm going to say, because I've got a negative and a positive, if I add these equations together, so add equation 3 and equation 4 together, my b's will cancel. So that will give me 17a is equal to 85. And then I divide both sides by 17, so a is going to be equal to 85 divided by 17 is going to be 5. Again, double check that on the calculator. I get very confident and then find I've made a mistake early on. 85 divided by 17 is equal to 5. Yeah, so that's the value that I'm using for a. I'm then going to substitute that value of a into one of my starting equations. So I'm going to substitute it into the first equation. That way, it doesn't really matter which one, but it just avoids having to deal with a negative number. So 3 lots of A would become 15, plus 2 lots of B, and that's got to be equal to 20. Minus 15 from both sides, 2B would be equal to 5. Divide both sides by 5, B would be equal to 2.5. And it's a 3-mark question, so I'm going to do a very quick check with equation 2, the one that I didn't use here. So 4 lots of A would become 20, minus 3 lots of B would be 7.5, and that would be equal to 12.5. So I know that I've got that answer right. So A is going to be equal to 5, and B is going to be equal to 2.5. Okay, question 5. Quadrilateral is made from 2 right-angled triangles. Okay, work out the size of angle X. Okay, right, I'm going to add a tiny bit more information to this. I'm going to say that that side and that side would be parallel if they're 2 right-angled triangles. That's not a huge amount of help. Right, so I'm going to work out this length here, which I will call Y first of all. So I'm going to be using Pythagoras to find the shorter side. So y squared is going to be equal to 13 squared minus 5 squared. So I'm just going to write that ready for my calculator as the square root of 13 squared minus 5 squared. And then it will simplify that. So the square root of 13 squared minus 5 squared. And that gives me 12. I should have spotted that's a Pythagorean triplet. So I'm now going to say that I'm trying to work out the angle. So this side would be, let's change pen, or try to change pen. So this side is going to be my opposite, this side is going to be my adjacent, so I'm using my tan ratio, so tan is equal to opposite over adjacent. So I'm going to go straight to saying that x is going to be equal to tan to the minus 1 of the opposite side, y, which I've just found out to be 12, divided by the adjacent, which is 10. So shift tan. I'm going to type it in like that. I could obviously simplify that down to 6 over 5, but there's no advantage to it on a calculator paper because it will automatically do it for me. So for that, I'm looking at, and I have this habit of writing down more decimals than I need. And I just put dot 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 to imply that I've not rounded at all. That's just, and then I will round. So that's going to be 50 point, and then I'm rounding to that figure there. The number behind it is a 9, so it would go up to a 2. Okay, here are 4 graphs. So we've got, I'll talk you through them straight away. So this is going to be a quadratic graph. So y is equal to something x squared. This is a linear graph, so y is equal to mx plus c. This is a reciprocal graph, so y is equal to 1 over ax. And then this is a cubic graph, so y is equal to x cubed. Obviously there'll be other parts, but that's just kind of the general pattern of these graphs. Write down the letter that could represent the equation half x plus 3, so that's going to be a linear graph, so that's going to be graph B. X cubed, that's going to be graph D, and then 1 over x, that's got to be graph C. Okay, here are 2 column vectors, A and B. On the grid below, draw the column vector of 2A plus B. So I will do this 2 ways. My first method is going to be by finding what the resultant would be. So 2 lots of A would be 6 and 2, plus B, which is minus 1, 2. So my resultant vector would be 5, 4. And I can draw that as 5, 4 straight away. I'm going to change pen and just show you. So I'll say how I would do it. So I'll pick a starting point. I'm going 5 to the right and 4 up. So I'll pick a point and then I would just draw 4 squares and 5 squares across, 4 squares up. Alternatively, I could do it like this. So pick a starting point, and A is 3, 1. So that would be 1A, another A, and then 1B would be 1 and 2. So that would be my and provided I've done that right, we should find that that there represents 5 across and 4 up. So that does work. So that's 2A plus B. Okay, question 8. Rob wants to install a solar panel. Rob decides he needs 6 solar panels. Each solar panel costs £350. The other components required cost a total of £2,400. It will take 2 men 2 days to install the system. The labour is charged £150 per man per day. The average household will, with this system, will save £1,200 per year on electricity. If Rob has the system installed, how long will it take him until the money he saved will be equal to the initial cost? Okay, so we want 6 solar panels, each costing £350. We also need to add on the other components, which is £2,400, and we need to add on 2 men working for 2 days at a cost of £150 per day. So that's going to give us the total cost of the project. So 6 times by 350 plus 2,400 plus 2 times 2 times 150. So it's going to cost him a total of £5,100. So if the cost it saves, so that's what he spends, that's what he will save a year. So if we do that value divided by 1200, that gives us 4.25 years. So if Rob has the system, how long will it take until the money, given your year in years and months? So that's going to be 4 years, and 3/4 of a year. Sorry, a quarter of a year is 4 months. So it will be 12 divided by 4 is 3. So it will be 4 years and 3 months till he covers the cost. Nice question. Okay, question 9. Make M the subject of the formula. So I shouldn't need my calculator for this. I'm looking at my first step. I want to make M the subject. So my first step is to get rid of this denominator of 5n by times in by 5n on both sides. So 5ny will be equal to 3m plus 4. I then need to get rid of the plus 4. So 5ny plus 4 is equal to 3m. And then divide both sides by 3. I get 5ny plus 4 divided by 3 is equal to m. And now m is the subject, so m would be equal to 5ny plus 4 divided by 3. And I've made a minor mistake here. I'm just looking, so that should have been a minus. So that's correct now. Right, question 10. The price of a train ticket in 2020 was 3.5% higher than in 2019. The price of a ticket from Bristol to London in 2020 was £2.80 more than in 2019. Was more. Work out the price of the train ticket from Bristol to London in 2019. So that 2.8%. So whatever the price was, times by 1.0, times, no, we're just looking at the increase. So times by 0.35 is equal to £2.80. So if we want the original price, we would need to do 2.8 divided by 0.035. So the original price would have been 2.8 divided by 0.035. So the original price for the train ticket was £80. Where's that? Bristol to London. That's quite a far journey. So that sounds reasonable. Part B. The price of a train ticket increases by a further 3.5% per year for the following 3 years. If a train ticket from London to Sheffield in 2019 was £130, work out the price of the train ticket in 2022. So in effect, we're going to be doing 1.30 times by 3.5% increase would be a multiplier of 1.035. And we're doing that for 2019, 20, 21, 22. So to the power 3. And it also says 3 there. So 1.3 times by 1.035 to the power 3 gives us, so I've typed in 1.3 instead of 130, which $144.1333 dot. So the price is going to be £144.13. Okay, question 11. Izzy rolls 1 dice, Jim rolls 2 dice and adds the values together. Who is most likely to get the result of 6? So I found this a really interesting question. I was doing this with a student the other day. So I think in reality, if we view it as a sample space diagram, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm not going to fill all this in. adds the values together to get 6. So we've got a 6 there, a 6 there, a 6 there, a 6 there, and a 6 there. So we've got 1, 2, 3, 4, 5. So his probability is going to be, so I should have said that this is Jim, is 5 out of 36. And the probability of Lizzie doing it is going to be 1 out of 6. So Lizzie's is 1 out of 6. Which is the same as 6 out of 36. So 5 out of 36 is less than 1/6. So who's most likely to get a result of 6? That would be Jim. Sorry, who is most likely? That would be Lizzie. So yeah, there we go. Okay, question 12. The nth term of a sequence is 2n squared plus 1. Write down the first 3 terms of the sequence. So I'm going to use, and if you're not familiar with the table mode on your calculator, it can be really useful for questions like this. So let's just explain that again. So what I've done is I've gone into the mode of my calculator, and you have got modes on the more modern ones as well. These are actually slightly better on the more modern ones. So I'm typing this in as 2 times by x, 2 times by alpha x squared plus 1. So I've typed the sequence into my table function. I want to start at the value 1, and I want to end at the term 3, and I want to go in steps of 1, and that gives me my values. So I've just written table function to imply to my examiner that I've used the table function on my calculator for this question. The reason I've done that is if I just write the answer down without this kind of saying that I've used the table function, my examiner might think that I've just copied the answer off someone. If I've implied that I've used the table function on my calculator, then that's absolutely fine. Okay, and again, this was an interesting question. So the first 5 terms of the sequence are: find an expression in n for the nth term of this sequence. So I helped some students with this earlier yesterday, and they were really sort of overcomplicating it, which I understand because we don't get very many questions like this. So if I actually look at the numerator and the denominator as separate parts, if I look at the numerators are going up by 2. So if I were to describe the numerator as a sequence, it would be 2n plus 1, because they're all 1 bigger than the 2 times table. And then if I look at the denominator separately, 1, 4, 9, 16, 25 is just n squared. So all we're looking at is 2n plus 1 over n squared. And I really like that question. That is kind of fitting into the AO3, the kind of the reason and problem solving aspect. We don't very often look at sequences split like that. I saw a question a few years ago, it might have been on an A-level paper, where they were all simplified fractions, which did cause a lot of confusion. Okay, question 13. Katie and Nellie each have a combination padlock. Each padlock has 4 digits. On Katie's padlock, each digit contains the digits 0 to 8. On Nellie's padlock, each dial contains the digits 0 to 9. How many more possible combinations could be selected on Nellie's padlock than on Kate's padlock? Okay, so Katie's padlock, we've got 10 digits, and there are 4 possible combinations of that. So it would be 10 times 10 times 10 times 10, or 10 to the power 4. And on cases we've only got 9 digits, so that would be 9 to the power 4, or 9 times 9 times 9 times 9, because in effect you could have 1 followed by any of the digits, so that we've got 10 combinations. So let me just explain that a little bit better. So on Nelly's padlock, we could have the numbers 1 to 10, and then the next numbers could be again 1 to 10, so there are 10 possible combinations of that, and then that happens another 2 times, so it's 10 times 10 times 10 times 10. And likewise with Nelly's, we're only going there to 9, so there's 9 times 9 times 9 times 9. And I'm going to just use my calculator for that. So 10 to the power 4. Ooh, let's put it back into my standard mode. So 10 to the power 4 minus 9 to the power 4. So there are going to be a difference of 3,439 combinations. So 3,439. Nice question. Okay, question 14. Correct the nearest millimetre. The length of the side of a regular pentagon is 3.8 centimetres. Work out the upper bound for the perimeter of the pentagon, giving your answer in centimetres. Okay, so if the length of the pentagon is 3.8 and it's been rounded to 3.8 as opposed to 3. Let me just double check this. That would be 38 millimetres. So it's been rounded to that as opposed to 3.7 or 3.9. We don't need the lower bound, so it's a bit irrelevant me talking about it. But the lower bound would be 3.75. And the upper bound would be 3.85. So if we say length is, that would be the full bounds. We only want the upper bound though. So the upper bound for the perimeter of the pentagon, well, it's going to be 5 times by that. So 5 times by 3.85. So 5 times by 3.85 gives me 77 over 4, which is 19.25. Giving your answer in centimetres, we kept it in centimetres, so we're looking at 19.25. Oh, okay. So enlarge shape J by a scale factor of -2 with a centre of enlargement 0, 0. So what I'm going to do is I'm going to do this accurately on a different sort of platform. So I'm going to use my snipping tool. Actually, I want to cover everything. There we go, that's better. So if I snip that, okay, it just means that I can bring a ruler in. So what I'm going to do is, for any enlargement, particularly negative enlargement, if I draw a straight line going from points to points, and a good way of checking that is 3, 4, 3, 4, 3, 4. So I'm slightly out. There we go. So I draw. And I don't. Let's try that again. So I'm going to draw a straight line through the centre of enlargement, and a negative enlargement is going to come down this way. So I'm going to do that from that point, and I'm also going to do it from another point. So I'm going to go at this point, the bottom of the triangle. Again, I'm slightly out. I can see that I'm going 5 across and 1 up. So 5 across, 2, 4, 5. So I'm still slightly out. Is that better? 2, 4, 5, and 1 down. 2, 4, 5. Still ever so slightly out. There we go. So 2 lines. And then in effect I can take my ruler off just for now. So and I can count the squares. So if this square here is currently 2, 4, 5 across and 1 up, it's going to go. So currently from the centre of enlargement to the point, it's going to be 5, 1. If I times that by minus 2, then it's going to go minus 10 minus 2. So from the centre of enlargement, I need to go 10 across, 2, 4, 6, 8, 10, and 2 down. And that does line up perfectly. And then I'm going to look at this point here as well. Let's change colour just to show that. So that point there is going to be 3 across and 4 up. So 3, 4. So times by minus 2 is going to take me to minus 6, minus 8. So minus 6, 2, 4, 6. And then minus 8, 2, 4, 6, 8. So that point will move to there. And then from there, I can I only really needed to do it for 1 point, but so I'll use a third colour just to go purple. So if that square was 2 across from that point, it's going to go 4 in the opposite direction, so it will go to there. And then take my ruler, and it looks like I've miscounted something. Let's just look at this point again. This was 1, 2, 3, 4, 5. No, sorry, this one is 3, 4, so it should be 6, 8, 2, 4, 6, 2, 4, 6, 8. So I'll put this in the wrong place, I think. Let's just look again. I said minus 10, so 2, 4, 6, 8, 10. Yeah, there we go. So that point should have been there. So let's just take that and that out. So that point should have been there. And then we so instead of being 3 up, it should now be 6 up. 2, 4, 6. And instead of being 2 across, it should be 4 across. So spin my ruler around, a little bit time consuming, but so we're going across and then join those 2 points up. There we go. So that's my enlargement, and it's a triangle that's twice as big. So let's just double check. 3 and 2, so it should be 6, 2, 4, 6, and 3 and 4. So that would be my negative enlargement. Okay, and I'll do it on the sheet, and I'll do it kind of roughly by freehand, but that's the way I would recommend it. So that point there is going to go to, instead of 3 across, 2 up, it's going to go, sorry, instead of 3 to the right and 2 up, it's going to go 6 across, 2, 4, 6, 2 down. That point, instead of being 3 up and 3 to the right and 4 up, it's going to go 6 to the right and 8 down, 2, 4, 6, 8. And that point, instead of being 4 across and 2 up, it's going to go 10 across, 2, 4, 6, 8, 10, and 2 down. So that's going to be my triangle. Drawn very roughly freehand. It should look the same though. Let's just do it side by side. Should be able to move that. Yeah, we can kind of see. Yeah, that works fine. Right, question 16. Paddy has 2 jugs of lemonade. Jug A contains 600 millilitres of lemonade, which he made using syrup and sparkling water in the ratio of 1 to 3. I'm going to put a Y and a P there to stand for syrup and sparkling. Jug B contains 1.4, so we've got a difference in units. He made using syrup and sparkling water in a different ratio. Paddy mixes the 2 jugs of lemonade together, giving him a total of 2 litres. Okay, he calculates that the ratio of syrup to sparkling water in the mixture was 11 to 29. Work out the ratio of syrup to sparkling water for the lemonade that was in jug B. Okay, so I'm going to start by looking at the total. And again, your strategy for this can be completely different to mine, but we should end up with the same answer. So we're doing, and I'm going to stick with that Y to P. Syrup to sparkling is in the ratio of 11 to 29, and we've got 2 litres of that. So I'm going to call that, yeah, I'll call it 2 litres. No, I'll go millilitres, so 2000. So if I split that in the ratio, so that's the ratio, so I'll go for the amount now. So I've got a total of 40 parts. So if I do 2000 divided by 40, that tells me how much each part would be worth, and then I'm going to times by 11 and times by 29. So we'll kind of do that over here. So 2000 divided by 40 is going to give us a whole number, so 50. So each part is worth 50. So times by 11 gives me 550. And then for the sparkling water, I'm going to do 50 times by 29, which gives me 1450. So that's in the total. Let's just put 50 millilitres for each ratio. I'm then going to work at jug A. So jug A, that was in the ratio of 1 to 3. And we had 600 millilitres to split there. So 600 divided by the number of parts divided by 4. So each part for that is going to be worth 600 divided by 4. So each part is going to be worth 150. So the amount is going to be 150 and 450. Okay, so jug B must be, this one take away this one is going to be 400. So just to make that a little bit clearer. This value minus this value is 400. And then this value minus this value is 1000. Right, let's just check what we were asked. Work out the ratio of syrup to sparkling in the jug. So that's the amount. So the ratio is going to be, simplifying this, so it's going to be 2 to 5. Okay, there we go. Nice question. Okay, solve for x squared is equal to 8x plus 7, giving your answer to 2 decimal places. So this is kind of implying that we're using the quadratic formula. If I rearrange this, first of all, I would get 4x squared minus 8x plus 7 is equal to 0. So I'm not a massive fan of the quadratic formula, so I'm going to try doing it by completing the square. So if I take factor of 4 out, that would give me x squared minus 2x. So I've just factorised the first terms, plus 7 is equal to 0. So I'm now going to complete the square on this part here. So I'm going to say that that's 4. I'm going to put a big bracket in. X minus 1, half of this coefficient squared. And from that I need to subtract this term squared, so minus 1. Plus 7 is equal to 0. So if I kind of rearrange this now, so we'll multiply out the bracket, so we'll call it 4x minus 1 all squared. This will give me minus 4, so plus 3 is equal to 0. Minus 3 and then divide by 4, so x minus 1 squared is equal to minus 3 over 4. Square root and then take the 1 over to the other side, so x is going to be equal to 1 plus or minus the square root of a negative number, which isn't going to work. So I've made a mistake right at the beginning, which I'm going to rectify now. I feel quite embarrassed. That was a minus there, that was a minus there, that was a minus there, that was a minus, so minus 4, that should be minus 11. So that would be 11. Let's just double check those corrections. So that would be giving minus 4. Minus 4 minus 7 is minus 11. So that's better. over 4. So x is going to be equal to 1 plus or minus the square root of, and I'm going to actually do the square root, root 11 over 2. So if we get the calculator out, then 1 minus fractions root 11 over 2. So that gives me my first value minus, so x is equal to minus 0.658 ... or x is equal to, and then I'll just replay and change that negative to a positive. And then as a decimal, that's going to be 2.6583 ... So my two values then are going to be x is equal to minus 0.66, or x is going to be equal to 2.66. And I've done that by completing the square. There's nothing wrong with doing it by using the formula. I just, to be honest, being dyslexic, I struggle remembering formulas, and I haven't got a formula sheet to hand. And I missed off the second part of this. So if we look at part B, solve 2 to the power 2x divided by x cubed is equal to 33. So I'm going to treat this as, when we do this, we subtract the powers, and I'm also going to convert this to a power of 2. So that's going to be equal to 2 to the power 2x minus 3, and that's going to be equal to, well, 36 is 4 times by 16, so it's actually going to be 2 to the power 2, 4, 8, 12, 2, 4, 8, 16, 32, so to the power 4. Let's just double check that. Again, nothing wrong with making a silly arithmetic error, and it would help if I typed it incorrectly. So I've missed off a power. Glad I did that. So there we go. So that tells me then that 2x minus 3 is equal to 5. So 2x is going to be equal to 8. So x is going to be equal to 4. Right, question 18. This table shows information about the speed in miles per hour of some cars as they travel past the speed camera. Okay, on the grid below, draw a histogram to represent this information. So we've got the axes filled in. That's nice. That saves us a bit of time. So we're going to start by looking at the group width. So that's going to be 30. That's going to be 5. That's going to be 10. No, it's not. It's going to be 20. No, it's not. It's going to be 10. And then finally, that one's going to be 15. Okay, so the frequency density is going to be equal to the frequency divided by the group width. So if I go frequency density, and that's equal to frequency divided by class width. So if we kind of imagine we've got the space, we bring in an extra column of our own. Okay, so 12 divided by 30 is going to be equal to 0.4. 22 divided by 5 is going to be 4 2/5, so 4.4. 34 divided by 10 is going to be 3.4, and then finally 3 divided by 15 is going to be 1/5, so 0.2. Again, we can double check those calculations if you're not confident with them. And then to draw that on a frequency diagram, then on a histogram. So my first group is going from 0 to 30, and we're going to 0.4. So that's very low. So we're going really just 2 squares up. I don't think I can bring a ruler on this sheet. Which, yeah, we haven't got the option of bringing a ruler in. So let's just, I'll use a ruler on the screen, which isn't particularly great, so apologies. Okay, my next one is 4.4, so I'm going 4.4 is going to be up to there. and I'm going up across to 35. Oh, that didn't hit. My next one then is 3.4, so 3.4 is going to be there, and we're going to 45 with this bar. And then my final one is 0.2, going up to 60, so very low. Okay, so that's going to be my histogram. Part B, what do we reckon this will be? Let's have a look. What do you think the speed limit of the road is? Tick the appropriate box and give your reason. Okay, so I think the speed limit of the road is going to be, if I was guessing, so if we look at this, we've got, let's just look, so 32, so most, what do I reckon? I think I'm going to go 40, because most cars are under 40. Is that an option? Well, it's definitely not 60. 30 or 40 is where I'm debating. I'm going to go 40. And I'm going to go most cars are under 40. So we've got very few under 30. A large section between 30 and 40, not many over 40. So I'm going to go 40. My reason is most cars are under 40. Let's think about this. Past the speed camera. Yeah, so past the speed camera, most people, yeah, I'm definitely going with that. If it was a normal road and it just said 40 miles per hour on a road, I'd be tempted to go with 30 there, but as there's a speed camera, I know from driving, as soon as I see a speed camera, you know that you can't go above 40, or there we go. Okay, question 19. Here is a cone. Work out the volume of the cone, giving your answer to one decimal place. Okay, so the volume of a cone is equal to 1/3 times by the radius times by the radius squared times by the height of the cone, so times by the height. So this is going to be equal to 1/3 of pi times by 5 squared times by the height, which is 12. So we'll use our calculator for that. So I'll type it in just like that. 1/3 times by pi times by 5 squared times by the height, so times by 12. So the volume of that would be 100 pi. I'll write it down like that. And then to one decimal place, that's going to be 314.15926 ... So to one decimal place, I'm going to go 314.2. So a larger cone is mathematically similar to the cone. It has a surface area which is 4 times greater than the surface area of the cone. Work out the volume of this larger cone. So if the scale factor for the area is equal to 4, then the scale factor for the lengths are going to be square root of that, 2. So the scale factor of the volumes is going to be 2 cubed, which is going to be 8. So it's going to be 8 times as big. So 100 pi times by 8 is going to give me 800 pi, which is going to be equal to, so I want to times that value by 8. So 2513.27 274 ... So to the nearest integer, that's going to be 2513, possible unit mark here, so centimeters cubed. Okay, question 20. Prove that prove that 2n times by n plus 4 plus n minus 4 all squared is positive for all values of n. Is positive for all values of n. Okay, so we're going to simplify this as much as we can. So that's going to give me 2n squared plus 2n times by 4 would give me 8n plus, and if I square this out, I would get n squared minus 8n plus 16. So if I simplify this, then I'm going to get 3n squared plus these would cancel, so plus 16. So I think that's as simple as I can go, but that's fine. So any value squared, so any value for n will be squared, so will be positive. And adding 16 will still give a positive result. Okay, so in effect what we've said there is the only value for n, so if n was, for example, minus 7, minus 7 squared must be positive, and then a positive plus a positive must always be a positive. Okay, question 21. A helicopter flies 18 kilometers from an airport A to point B on a bearing of 0.35. So 18 kilometers on a bearing of 0.35. The helicopter then flies from B to C on a bearing of 130 degrees. Finally, the helicopter flies back to the airport on a bearing of 250. Work out the distance from A to C, giving your answer to 1 decimal place. So I'm going to draw a very rough sketch to help me with this. So we've got, let's say, point A, and we're travelling on a bearing of 0.35. So that's going to be kind of that angle. So 35 degrees. It then arrives at A, B. Let's just clear that up, 35. And that length there is 18. It then flies on a bearing of 130, so 130 is very roughly that kind of angle. 130, and then I want to end up with a bearing of roughly 150, so that's 360, 180, so it's not that far on that bearing. And gets to point C, and then flies on a bearing of 250, and we want to find this distance here. So I'll call that X for now. Right, so I've extracted the information from the question. I'm going to just take some of the letters out just to highlight them a bit better. So we've got A, B, and C. and we want to find x. So we've got a distance of x here, so I want to find out some of these missing angles. So the ones that I can work out then, so if that's 35, then that would be a supplementary angle, so that's going to be 145. And I'm going to say that we've got 130 there, that bearing there, or that distance there is going to be equal to 50. And from there I can work out the interior angles. I can work out this one. So that angle there is going to be 360 minus these two added together. So minus 275 is going to give me 85. So I know that inside angle is going to be 85, and I can work out this inside angle as well, or interior angle, and that's going to be 360 again minus, I've not written that very clearly, I think that was 50. Oops. Yeah, that was 50. Minus 300, so that angle there is going to be 60 degrees. And that's enough information for me to apply the sine rule. So x over sine of 85 is going to be equal to 18 over sine 60. So x is going to be equal to 18 sine 85 divided by sine 60. So if we go calculate for that then, so we're at that stage. So 18 times by sine of 85 divided by sine of 60. So we get the value of 20.70517. Right, what to one decimal place then, that's going to be 20.7, and again my unit kilometers. So somewhere on the papers there'll be a unit mark. Okay, and that brings us to the end of the paper. Really good paper, really enjoyed doing that. There's some really nice challenging questions on that. So I hope you found that useful. Again, huge amount of credit to Third Space Learning. They've produced a really nice set of practice papers there. I hope you found that useful. I will chapter each of these questions, so if you're struggling with a particular area, you can kind of get from the chapter name or in the link on the video what the topic was. Thank you very much for your time in watching the video, and I will see you soon.